find all functions f of x such that f prime of x equals 4 sine of x plus 2x to the fifth plus the square root of x all over x. Now there's a lot going on here, but there's a couple of things I want to think about. We are asked to find a function with a given derivative. So what we are doing is we are anti-differentiating, right? We're given the derivative, we want the original function, so we are anti-differentiating. And we've mentioned earlier in another example that when we have a function that has multiple terms and we want to find the antiderivative, we can find them term by term. But here's the thing, this thing in the middle can also be split up into two terms, and we can do some simplifying here. So let's look at that. We can rewrite our derivative as 4 sine of x plus 2x to the fifth over x plus root x over x. And we can even simplify those fractions. We're going to keep our 4 sine of x. And then here, 2x to the fifth divided by x is just 2x to the fourth. And then we can look at this last one, the square root of x over x. There's different ways of thinking about this, but we know that x is the square root of x times the square root of x. So if we write it like that, we can actually cancel out a square root of x and write this as 1 over root x. And that's the same as x to the negative 1/2. Negative because it's in the denominator and 1/2 because it's a square root. So this is the same as x to the negative 1/2. And then we can anti-differentiate each of these. I'm not going to use capital F of x here. I'm just going to use regular f of x because we already have a derivative notation here. So this is the derivative of lowercase f. So if we want to know the regular function, that's just lowercase f of x. Now we'll do this one term at a time. We've got the derivative of 4 times sine of x. The antiderivative of 4 times sine of x, The antiderivative of sine of x, we already saw is negative cosine of x. And that constant multiplier of 4 is going to turn this into negative 4 cosine of x. And then plus, remember we had that power rule. When we've got the antiderivative of a power, we increase the exponent by 1 and then put that new exponent in the denominator. So that's going to be x to the fifth over 5 with that factor of 2 out front. And then similarly, we can use that same power rule here. We add 1 to the exponent. Negative 1/2 plus 1 is positive 1/2. So that's going to be x to the positive 1/2 divided by 1/2. And we can simplify that a little bit. Dividing by 1/2 is the same as multiplying by 2. So we've got negative 4 cosine of x plus 2/5 x to the fifth, and then plus 2. And we can either write x to the 1/2 or we can write square root of x. Both of those are equivalent. And so we end up with our function. If you want to check if you have the correct antiderivative, all you need to do is differentiate what you have and see if you end up with what you started with. I would recommend you do that not every single problem, but a few times as you're working through these, just if you want to test whether or not you've done it correctly. It's good to get a little bit of practice with that.